Okay, welcome everybody. It's time to get started. I am Lester Knutsen of Advanced Data Tools, and this is the next in our series of Informix Performance Tuning webcast. With me on this webcast is Mike Walker, and we also have Art Cagle. And Mike or Art, if you can't hear me, please text me on my phone, because I have no way of knowing whether you can hear me or not. I hope all is going well. Anyway, this is going to be an exciting webcast. I want to talk about SQL Trace, and then we want to share with you some remote DBA monitoring stuff that we've been doing here. Just as a reminder, I'm Lester Knutsen with Advanced Data Tools and been working with Informix since 1983. With me today is Mike Walker, who currently is in Denver, but he's originally from England, and he's the primary consultant responsible for all our remote monitoring systems that we do here, and he'll share some information with you. And so what we want to do is talk a little bit about SQL Trace and how to monitor user sessions with that, and then DBA monitoring tips, and a little bit about a dashboard tool we use called YellowFin that we use in our DBA monitoring. So I want to start off with SQL Trace. This was actually something I tried to get done in my last presentation about 2 months ago on the Sysmaster database and just ran out of time. But in version 11, it's a new feature that allows you to create detailed statistics on all the SQL that's currently running. So you have to have version 11 for this to work. Now, by default, SQL Trace is off, but it's very easy to turn it on, and I'm going to go through some examples, and we'll do some live demo of turning it on and off. Now, what it does is it creates a SQL Trace Buffer in your virtual segment of memory. So it does take some memory when you turn it on. If you don't turn it on, it doesn't take any memory at all. And this buffer is a first in, last out type of buffer. When you turn it on, it buffers SQL statements until the buffer is full. Once the buffer is full, the oldest SQL statements and stats are discarded to make room for new SQL statements. I can fill up this buffer in seconds on a very busy system. In fact, I'm going to show you that in just a little bit when we get to the demo part of this. The default amount of memory is about 2 megs, but you can increase it or decrease it. This is probably, I think, the main performance hit of turning it on is it does take away virtual memory, so it leaves less memory for your other applications. So if you make your SQL buffer too big, you can actually grind your whole system to a halt, and I've done that before. The default is rather small, and it means the SQL statements turn over pretty fast. Now, there are 3 levels of trace, low, medium, and high. And low is the default when you turn it on, and this collects a lot of data. It has stats about the SQL statement, the SQL statement itself, quite a bit of data, and in most cases it collects about everything you need. Medium adds a little bit more, particularly the database name, and that's the one thing I wish was in low that is not there. You can see the SQL statement, but if you have multiple databases in low, you don't know which database that SQL statement is running on. You have to go to medium to see that. And then high creates a lot more data. This is an example, though, of really the output from SQL Trace. And what you see, and really it's the database name and some detail in the host variable in the SQL statement. That's the main difference. Everything else is pretty much the same. So doing SQL Trace Low gets you a lot of benefit. Now, the other thing you can do is configure the number of SQL statements to trace. And the default is 1,000, and the default size of data is about 2K. You can increase that. If you go with the defaults, that means when the 1,001st SQL statement is run, the first statement that was collected gets discarded to make room for that. And you can also specify what user you want to trace, or all users, which is the default. And one way of turning it on is in your onconfig file. There's a line called SQL Trace. The default is low. N traces is the number of SQL statements you want to trace. The size is the size in K for those statements, and then the mode is global or specify a user list. If you put in a user name that doesn't exist, it just won't trace anything. It'll run trace and not collect any data. Now, what kind of information does it collect? It collects the user ID, the session ID, if you have medium or high, the database, the type of SQL, how long the SQL statement took, the time it took to complete the SQL statement, the actual SQL statement, and the database isolation. In addition, it contains a lot of stats. Some of them are the number of reads and writes to buffers and to disk, the number of sorts, the number of lock requests and lock waits, how many logical logs were used, how many indexes were used, and a couple I like, it gives you the estimated cost and the estimated number of rows, and then it gives you the actual number of rows returned. This is a real good comparison to see how good your stats are. If it estimates 1,000 rows and it returns 10,000 rows, that probably means your update stats is off, and so this is a good way of checking that out. Now, there are a couple of SysMaster tables that are views into the SQL buffer. So think of the SQL buffer as this chunk of memory, and these SysMaster tables as raw table views into that chunk of memory. The main one is SQL Trace, which shows you all the information about a single SQL statement. And it has tons of information about that SQL statement. Everything from the session ID, the time, how long it took, when the statement started, when it finished, the type of statement, how many logs it took, sorts, how many disk sorts, memory sorts, number of times the SQL ran, and on and on and on. So there's a lot of really good information here for debugging and figuring out where your problem SQL statements are. I've said this before, what I really like is it gives you the estimated cost, right here, which is the estimated optimizer cost for each SQL statement. And that's one of the things I use when I turn this on to look for expensive SQL statements that can be tuned. Now, you get this data. How do you see it? Well, there are a couple of ways to see it. One is to look at that table I just showed you, SQL Trace in the SysMaster database. A second thing is to use onstat-g HIS to show you the current SQL Trace results. And I'm just going to flip over here so I can show you some examples. Right now I'm running a benchmark with 1,000 users connected to the system. and we're doing about 47,000 transactions a minute. So if I do an onstat minus U, I have 1,019 active users. If I do an onstat minus GHIS, I have SQL Trace disabled. So I'm just going to go in and run a very simple command that is going to just turn it on. And I'm going to talk about this in a little bit. And that turns it on. And now if I do an onstat minus G history, I actually have tons of information about all the SQL statements that are in the buffer. Just to give you an idea, in the last couple of minutes, I've got 51,000 lines of information. So there's a lot of information that this collects very quickly. The SQL API that you can use, and this is, I think, the preferred way to turn SQL tracing on and off, is to use task or the admin function in the sysadmin database. The task function will do something and then gives you a text message. The admin function will do something and only give you a number. And that tells you what the results were. So if I come over here and I go back into DB Access, and let's take a look at the info, and it tells me, okay, I've got it on. It tells me how many traces, how big the buffer is, what level I have it set at, and what mode. Level is low, medium, high. Mode is going to be global or specifying specific users. So this gives me a quick snapshot of where my SQL is. Now, there's a lot you can do with this SQL API, and I really think this is the best way to run it. Info gives you info, off turns it off. Suspend and resume will suspend it temporarily, and resume will then resume it. SQL Trace on will turn it on, and you can also pass it the number of SQL statements to trace, the size, the level, and the mode when you turn it on. If you don't pass it that, it will go to the default settings. You can also do SQL tracing by database, and this is really what I find more helpful. If you can focus in on a database or a user that you're trying to find the problem SQL for, this narrows it down. So you can say, set SQL tracing database add and give it a database name, and it will only do tracing for that database. Instead of all the databases you have on your system. You can say SQL Trace clear, and it will clear all the databases, or remove, and it will remove a database from what you are tracing. You can also use the API to set up SQL tracing for a session, and you can say clear, which clears the data from that session, off or on, which turns it on or off for a session ID. You can add a user, which then adds that user to the list of users that are being traced. And if you have global, all users are being traced. This only really is helpful when you don't have global on. And then you can do remove or list to see what users you're tracing. Now, one little script Art wrote, which I kind of like, is a shell script that allows you to quickly put together what you want in SQL Trace to turn it on. So this prompts you for the number of traces, the size, the level, whether it's user or global. and then passes it to DB Access and runs it with all that. It's a nice quick way to turn it on and off for your environment. And this is really what you need to do, is get a couple of scripts like this that you can use to set up SQL tracing in your environment so that when you want it on, you can turn it on very quickly, and when you've got your information, turn it off very, very quickly. So let's take a look at some examples of SQL tracing and what's going on here. So, like I told you earlier, I'm running a open source benchmark that we used for the fastest DBA contest. And I've got SQL tracing on now, level low, global. And I have a little script here that will show me give me some information about the SQL tracing. And then it goes out and actually looks at the data that it's collected. So first line there tells me it's on, how many traces it is. The second line is from SQL Trace Info, which is a Sysmaster table. And the key thing to notice here is this line right here says I have 2,000 traces on, but there have been 1,756 SQL statements in the last few minutes. That's probably, you guys saw me turn it on, so that was probably about 5–10 minutes ago. I've done over 1.7 million SQL statements. And most of those have been discarded, and I've only got the last 2,000 in right now. This count tells me how many statements are in the database, and if I hit next, I can actually start taking a look at some of the detail. So here's an update statement. It tells me the time it began. It tells me the session ID that ran that update statement. It gives me some information about, and this is an OLTP system, so I know this is a very fast update statement. Some things about the cost and average execution time. It gives me the update statement itself. Because I did low, it doesn't tell me the database. Medium would tell me the database, which I think is an advantage when you don't know the database. If you know the database, low is probably good for everything you need to do. And I could sit here and do next, 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 next until we've gone through 2,000 rows. Now, this is a dynamic table. It's a peek into shared memory. So as I'm looking at this data, the data may change. I may see a row that's interesting and say, oh, let's go back and see it. And if that SQL statement has been pushed off, it's going to be gone and not there anymore. So it is dynamic. Now, let's do a couple things here. Let's change the tracing from low to medium. And so I'm running a script. I just switched it from low to medium. And I'll go back and run my SQL info. And it tells me that it's on medium. Let's take a look at some data. And again, it's seen now over 2.6 million SQL statements. So it's only saving the last 2,000. And if you look through this, the main difference is now it has the database here that I'm selecting. And has a full SQL, how long this SQL took, estimated number of rows, actual rows. This is on a pretty fine-tuned database right now. So everything should be real fast. And if I do the same thing, and let's run it high. So the only change I'm making is a script to run SQL tracing high. Go back and let's take a look at the data. It tells me now that the level is high. I'm still mode global, and still only have 2,000 SQL statements, but now I've seen 2.8 million SQL statements have gone through the trace buffer. And get a little bit more data. Where high really becomes helpful is when you have stored procedures you're trying to track, and I don't have any of those here to show you. So, as you can see, this is really useful information. It goes through that buffer really fast. If you make the buffer really big, and that was my first thought with this, is I'll make it really big. I've actually had systems run out of memory in doing that. So you need to do some very careful math. The buffer comes out of the virtual segment, so you need to go see how big is your virtual segment, how full is it, how much free space do you have there. And a quick and easy way to do that is to run the onstat -g seg. Whoops, I've got too many virtual segments, probably from running this, or I've got all these extra virtual segments that have been allocated because I've been running this. And this is what happens when you run SQL Trace and you don't have enough memory in your virtual segment. You'll get all these additional virtual segments added to your database. And it just keeps growing like this. So be very careful with that. Now, so how do you save SQL trace data? In version 12.1 and in the later versions of 7, I'm running 7 right now, and I don't have this in my version of 11.7. But I know the later versions of 11.7, there is a scheduler task called Save SQL Trace. And a very simple way to find out if you have it or not is go to your Informix dir, etc, sysadmin directory, and what you're doing is looking for a script called SQL capture. And if the script just has a closed database, you have an earlier version that really doesn't do anything. If I go to one of my other systems here, that's on version 12, and I look at the script, you can see that it goes out there and in the sysadmin database creates some monitor tables, and then based on how often you tell it to, it will copy the data from the buffer to these monitoring tables. And again, you've seen how quickly it has gone through data on my system. The act of copying data to a real table from memory can take some overhead. So you need to think carefully about how you do this. But it is there, and you can copy it to real tables. You also need to make sure you have space for these real tables in the sysadmin database. One of my recommendations here is you always move the sysadmin database to another real DB space out of the root DB space, and I've talked about that on my talks in sysadmin database. So that's key to do it. And then all you need to do is just update the task, which says save SQL Trace, and you want to enable it to T, not F as I have here. I copied the wrong one. That should be a T there instead of an F, which will then enables copying this, and you'll have your data saved. So here's the script you can take a look at to see how it saves the data. You can also work with this script to modify it to put it in your own space. A lot of times what I like to do is just unload the data. And I'll unload the data and then take it on to another system to analyze at a later date. To me, that's the biggest benefit. That way you don't hurt your production system by adding the overhead of copying it all. Just unload it and then look at it on one of your other systems. So, a couple of recommendations on this. This is a really powerful tool for debugging SQL, especially when you're dealing with a package where you can't see the SQL, the application developers don't want to share it, or the source code is not available. My main recommendation is use the sysadmin task function to turn it on and off. It's much more flexible than the onConfig entry. You want to keep the number and the size of the SQL buffer as small as possible because making it too big will affect virtual memory. I actually, other than that, have not found a performance hit with turning it on. Doing the benchmark we're doing right now with SQL Trace running, I'm getting 68,000 transactions a minute. And I can turn SQL Trace off and you won't even notice it. In fact, let's do that right now. That's one of the things I meant to do earlier. So if I come here and go in and let's just turn SQL Trace off. So SQL Trace is off. I didn't get a big speed up in performance. So the actual tracing itself doesn't have that much overhead. The memory usage of the tracing, I think, is where the overhead is. And so be careful, look carefully at how much data you want to save. Oh, and I should say, once you turn it off, I meant to point this out, that data is gone. Now if I come back here and do a select, I have no rows out there. So turning it off actually deletes all the data from the buffer. So don't make the mistake of saying, okay, I've captured some data, I'll turn it off and then go look at it. When you go back and look at it, the data's all gone. Unload it before you turn it off. I find it really helpful to focus, if you can, on a database or a user that may be the problem child, because you can specify a user session ID or a database and just do SQL Trace for that. So this is a powerful tool to add to your DBA toolkit here. Now, I want to talk about remote DBA monitoring, and I'm going to turn it over to Mike Walker. And I'm going to unmute Mike first. Mike, are you there?
I am, yeah.
Okay, welcome. Say hello to everybody.
Hey, everybody. Les, did you want to give me control here?
I'm going to give you control and make you the presenter. Everyone just give us a few minutes while Mike gets set up here.
Right. Okay, can you see that, Lester?
Yep, I see it perfect. Thank you, Mike.
Sure. Hang on a second. All right, so Lester has just been talking about how to monitor your SQL. So that's kind of a nice low level there. Now, the things that we've been doing recently, we've been looking at things at a higher level, so how to monitor your databases. Now, most of you probably already have some sort of monitoring in place, but I'd like to give you some examples of what we do to monitor our instances and the instances of some of our customers. There we go. Okay, so we set up some scripts, and they're Unix scripts, and they run at regular intervals, and it's just scheduled through cron. And they go out there and gather information on your instances, different sorts of information, and they query sysmaster that you're all familiar with. They run some onstats, and we compile all that information and send it up to our servers where we load it into some databases. And we run on different schedules. We run some of these scripts hourly, and we run some daily. The hourly scripts are looking at things like the CPU usage at that time, the memory usage, the sessions that are running, those kind of things. And then the daily stuff is more like, when's the last time did you run a backup? We grab some performance metrics, look at table sizings, how big are some of your tables, and table usage. Now, we take all that information, we load it into a database, a single database on our server, so we can then query all that information later on. So that's more like the big approach where you're trying to track stuff over time and look for maybe what's got a lot of sequential scans and stuff. But the other thing that you want to look at are the urgent problems. My database has crashed, or my instance has crashed, or we got some serious problems that we need to address right away. Now, so we've got some additional Unix scripts, and they run more regularly, and we can configure that differently depending on how big a footprint we want or don't want. And the sort of things we look for here, we might look for, do we have enough space in our DB spaces? And we can set up a threshold. Say, okay, right, this DB space, we need an alert if it drops below 10%. Whereas some of your larger DB spaces, you may only want an alert if it goes below maybe 2% or 1%. You may want an alert if your HDR is not running, or if your logical logs are not backing up. Now, with version, I think it was 11.5 that started, there's a pH alert table in the sysadmin database, and that's really useful for querying that to find out some of your critical information. So if you haven't taken a look at that, it's well worth a look. Some of the older, or before 11.5, we may need to put something into the alarm program. And of course, that would be called for these different events, and then we can trigger sending a file up to our servers, and that sends an email. Doing it that way, we don't need to have use an email client on a customer's computer, customer server. Instead, all we need to do is trigger a file on ours, and we'll send the email. And there's all sorts of things you can check with the urgent stuff. Okay, I'm just going to give you some examples now. Here's one of the things we did for one of our machines. We linked it into our UPS. So if our UPS just starts up and we lose our mains power, then we'll get an email from that. And here's an urgent alert that comes because our DB space dropped below a certain threshold. And we've set it up so you don't get emails every day or every few minutes or anything. It'll send one, and then you'll get another email when the situation is resolved. Now, we're gathering all of this data, both the urgent data and the hourly data and the daily data, and we're putting it all into a database on our server, and which is great because now we can not just query the current status, but we can also go back and look at history. So we decided to use a BI tool out there called YellowFin. And this is a web-based tool that allows us to query this data. I've got some examples here, and I put these in a, I put these in the presentation here, but I can give you a live demo, all being well. Okay, it should show in just a second. Let me know when it, Lester, if you let me know when it appears. Okay, hopefully that's showing up for everybody. So this is just running in Internet Explorer. I'm going to log in here to YellowFin. Oh, Lester, if you could stop the your benchmark that you're running, or the test. This is running on the same server,
yep.
So it might be a
I just stopped it, Mike.
Okay, thank you. Okay, so we've set up a dashboard here, and we can use this to report on all of our customers, but I've just limiting it right now to our own ADTC servers. And this just gives you a quick screen here of on this dashboard showing you the service that we're monitoring. We're monitoring 2 separate machines and a total of, 5 instances. And I've got an 11.7 instance, we've got a couple of 12.10 instances, and a 10 instance. Now, we've got these little colors here indicating whether things are good or bad. And you can see that 2 of our instances are currently offline. So obviously that looks a little scary, but I can also see the last time we received any information from these. And this server here happens to be one of the ones we use for the EVP testing, and it's now offline. And so we've also turned off the monitoring for it. So here this is showing, hey, we haven't received, this will show up in red if we haven't received anything for 24 hours. And that tells us that we might want to look at this. In this case, I know it's okay. But for this 10 instance, we received something recently, and the monitoring told us, hey, the monitoring's working, the machine's up, but the instance is down. We also keep track on this screen of the percentage of logs that have not been backed up. We've had some issues with logical log backups for active clients, that problems with backing those up, they fail, engine hangs. So we're more proactive now in looking at these kind of things. And we set this up in YellowFin. You can just click on any of these things here, and it'll go through to another report. And this here is a report of the logical logs. Bring this up, and I can see, oh, okay, there's 43 logical logs. These are the limits of when to send alerts out. If we hit some of these limits, so we can do it either by a percentage not backed up, or by, when you hit, in this case, when you hit 4 logs not backed up, then send an alert. This is the log ID. We're not replicating in this particular instance. And that's it for the logical log things. So going back to my dashboard, we can also look at the free space for all our clients, or in this case, again, limited to our ADTC servers. And here we go. So here's all our DB spaces, and the screen's a little limited here because I dropped the resolution, but I can drill in by which machine we want to look at. If I look at Newton, it's got 1 instance on it. Hit go, it will refresh this screen here. It will run another report. So here I've got a little view on all of our DB spaces, and it tells me if they're blob space or smart blob or whatever, but this is really what I'm interested in. I can look at the low space. And here I am showing our physical log and our logical log, so of course we're using the majority of those. But I can also drill in on a particular DB space and view it over time. I think this one, let's take a look at this guy. This is one of the DB spaces we use to store some of this monitoring data. And so I can see in this little graph here, let's just simplify it a bit to show the amount of free space in this DB space. And you can see from the graph how it changes over time. You can see that for this particular instance, we're loading stuff every month. So we see this little step pattern, which is kind of cool. And then we were running low on space, so I added some space not long ago. And this is just nice Yellowfin stuff. You can change these little markers here, and you can drill in further, and it'll scale the graph for the time period that we selected. It's really quite nice. Okay, so that's some stuff that we're doing with Yellowfin, built on top of our monitoring. And now you can look back and you can look at actual growth and trends, see table usage over time, all useful stuff. And let me flip back to my presentation here. So these are just screenshots that I've put in here. Same thing we've just gone through. Now, Yellowfin can also send out emails, on either just regular emails or when particular triggers happen. Like, oops, my DB space is below 10% free, whatever. So we can do that. And here's an example of an email. So it looks just like the dashboard we saw, but this is just a grab of an email that I received about the status of our servers.
Yeah, if I can interrupt, Mike, I think this is actually one of the best things. I don't have time to go look at a dashboard someplace because I travel a lot and I'm all over the place. But I get an email. Mike's got it set up so I get an email every hour basically telling me what the dashboard of all our servers looks like, which is really helpful.
Yeah, and that's exactly it. You don't have to go and actually look at it. It'll send you an email. You just take a glance at it. Okay, all is good. I'm happy. Now, so that's the Yellowfin piece. We also create emails based on all of this information that we have in our database, because now we can just run simple queries on it. And I produce a HTML email, and I'm going to show you some examples of the sorts of things that we can we monitor and we can distribute. So it's kind of broken into different categories. First of all, we've got the current status. Is everything good? Is everything up? Are we good to go? We can compare some of the information against the previous month, so we can see a trend. And we also report on certain information like number of extents, that kind of things. Things that might indicate we may need to do some cleanup of stuff, or things that might be performance problems. So I'm going to go through and show you some examples of things in this email. So this is an HTML email, so we can do tables and that kind of stuff, and pretty colors and things. So it starts off, the email starts off with how long things have been up. We summarize the alerts that we've received, and PH alert gives us a type of error. There's a warning or information, and then a color which indicates the severity. And we group these, and if there's multiple with a certain message, I'll kind of summarize those. Otherwise, this email is getting kind of long. So we've got a summary at the top, which just counts, and then a summary of the messages. Moving on, you can see that the last archive here was 265 days ago. So it shows up in red because that's kind of a bit of a long time ago, and we may want to do a backup. And of our DB spaces, were they all included in that last backup? And some of them weren't. Some of these are DB spaces that have been added since that last backup. So if all the DB spaces were included, then this would not say no, would not be in red, and you'd not see this little table here. Going on, we see if any DB spaces are below the threshold, and this one's right at the threshold. All the chunks are online. If they weren't, this would show up in red, and we'd have another table of our down chunks. Logical logs back up. Data replication is not set up on this instance, and this is nice. You're probably familiar with a lot of the performance metrics that we've seen before, like the buffer turnover ratio, and sequential scan rate, things like that, and just the cache thing. So we can keep an eye here on how things are looking, both how they are right now and the range they've been over the last month, the average, and the previous average for last month. So we can get some kind of idea of trends. And there's the warning and critical threshold. So in the case of the read cache, we want a nice high number, and it shows up in green because we're well above 95%. So this is really nice. So just to get a quick idea of the health of your server. We can look at the checkpoints, and here's an example. So we've got some checkpoints here that are summarized, and then we look at the longest checkpoints. We can see here for this particular customer, we had a 6-second checkpoint at 3 o'clock, so middle of the afternoon, and we can see that there was one session waiting on that. So that's good information, and then we can also graph stuff. We use Perl to generate a GIF file. There's a Perl module, GD graph, and we run that, run a query, produces an unload file, then use Perl to turn that into a GIF, and then insert it into the email. So we've got a graph here for the tables that we're hitting pretty hard, broken down by the reads and the writes, and you can see here this table, Mon table profile sysadmin is getting a lot of reads. This is not a very active database, so that's why the sysadmin stuff is showing up a lot. We can see how much space is being used for each of our DB spaces, where the orange shows how much is used and the blue is how much is allocated. We can look at the buffer turnover ratio and how it's changed over time. And the little lines here, if you can see those, these horizontal lines show our ideal range, or well, not our ideal range, but our warning and our critical. We'd really like it to be below that orange line if possible, but we can see trends here. We can look at the extents, how many, which of our tables have, in this case, over 10 extents. And we can look at our DB spaces, how they've changed over time. And the sequential scan information, what tables have we got a lot of scans on. So this, after seeing this might be, this isn't critical, but this may give you an idea of like, hey, we might get better performance if we start tuning some of these tables. And we also show anything waiting on locks. So that's an example of an email that we can distribute daily, weekly, whatever. And also we can configure it to show urgent information daily, or maybe, and like maybe every week you get a more in-depth email that has some of this other information like the extents and stuff, so you don't overwhelm yourself. So that's the information, that's the monitoring that we're doing both for ourselves and for some of our customers. And so we've shown you how we can trigger urgent alerts while at the same time gathering data for more of a trend analysis and then sending out emails and also monitoring through YellowFin, which is really quite a nice tool there. And Lester, that's all I have. I hand it back to you now.
Okay,
I'll still drive, but you can do the talking.
Thank you, Mike. So this is just sort of a description of people always ask, what do you do at Advanced Data Tools for remote DBA services? There are probably about 100 servers we are monitoring right now. And we have a standard, which is business hours, a premium support, which is 24/7. And then we have customized support offerings for people who want different customized levels of support. And it's everything from Art is going down to help someone do an upgrade over the 4th of July holiday to we actually have 2 upgrades happening this week. I don't know why everybody picks the 4th of July to take their systems down and upgrade them, but we've got a busy week this week because of that. And, it's just monitoring it, and if nothing happens, everything's good, and then when something happens, you have somebody to call. And and continue on. So, Mike, let's go to the next slide. Now, I want to talk about a couple of things coming up before we turn over to questions. And for questions, if you can find the chat button in the WebEx, and what we'll do is we'll take questions via the WebEx chat and just send a chat message to me, and I'll see that, and depending on whether it's me or Mike or Art, we'll do that. But while you're looking for the chat button and coming up with your questions, let me talk about our next webcast. The fastest DBA contest. We were actually going to start that this week. I'm still testing it. We've got some exciting new things we're going to do this year. We're going to start it next week, and we're going to kick it off with a webcast next Tuesday, July 9th at 2 p.m., the same time. And we'll talk about it then. We'll show you what it's going to be. The DBA contest this year is going to be a mix of two things. One is you will have 1,000 users doing an OLTP benchmark like we did last year, plus at the same time a batch billing job running. And the goal is to balance OLTP and batch billing at the same time. And there'll be two parts to the challenge. One is tuning the onConfig file, and the second one is tuning the SQL for the batch billing job. We're going to allow you to change the SQL, optimize it. I purposely made it really bad SQL, so there should be some obvious things to change. And Mike, if you can hit the next slide, please. You know, it's going to be a lot of fun. If you go out to our website and Advanced Data Tools /Informix, you'll see details about the previous contest. We also want to give a lot of people a chance to win. We're giving away an iPad again this year, and the winner will get an iPad, but then we'll have a lot of options for you know, the fastest, youngest DBA, the fastest, newest to Informix DBA, the fastest DBA from international DBA, and we'll have several options like that. So there'll be a lot of opportunity to enter the contest and win. And so tune in next week, 2 o'clock, same time, and we'll talk about that. And there'll be a lot more new details then. Mike, next slide, please. The other thing I want to mention is we have an advanced Informix Performance Tuning course coming up in July. We already have 2 people registered, so it's going to be a small focus course, but we do have room for 2 more folks right now. The September course is almost full. Just wanted to give everybody a heads up on that. The regular Informix for database administrators, I think we have 6 or 7 people already registered for that, and it's almost full. So if you're interested, please give us a ping about that. And next slide, Mike. Questions? Okay, and Art, I'm going to unmute you. Art, are you there?
I'm here.
Okay. Before we go to questions, Art, do you have any comments, anything you'd like to add?
No, nothing. The only thing I would add is, as Mike said, or you said, to unload the data from the SQL tracing. Another alternative would be to bring up a separate instance and copy it over there. So,
yeah, that's
just get it out, keep it out of your database.
That's really what you want to do, is get it out of production. Put it someplace else where you can work with it.
Yeah.
Cool. Well, we're open for questions. We've got about 4 minutes left here. And if you can find the chat button, and if you have a question, just type it into the chat and we'll see it.
If you haven't found the chat button yet, if you up on top of your screen where it says viewing Mike Walker's applications, if you hover over that, you'll see the chat button pop up.
And I'm not seeing any questions yet, so I'll give you all a minute. If you don't have any questions, please feel free to email us at any time after this. And Art's always on the Informix mailing list, and then glad to answer your questions there, and Mike and I will try and get back to you when we can. Well, since I don't see any questions, what's the next slide, Mike? I think that's it. Thank you guys all for attending.
Thanks, everybody.
Really appreciate your and comments like James just texted me. I love this. Thank you, James. Appreciate your comments there. And look forward to, I hope you guys can join us next Tuesday. At least you don't have to participate, but find out about it. It's always an interesting contest to at least know what's going on. And we'll, in August, we'll have another webcast where we'll have the results, and we'll tell you what kind of tricks the fastest DBAs used to get things going. So once again, thank you all, and we'll talk to you all next week or in August.